Hello everyone. Today's topic is about Hubble's law and the age of the universe. Okay. The last lesson we talked about the expanding universe. So this lesson we're talking about Hubble's and the age of universe. Okay. So this is just tell us how to calculate the expanding of the universe. Okay. So let's move to the first part about Hubble's law. So last time we talked about there's a redshift between the rays, right? So that means the universe expanding or universe is moving away from us, right? So here you can find that the redshift has like we can calculate it as sometimes, okay. You can find a very distant galaxy, you can find the redshift is all very big. And the distant galaxy, the redshift is smaller. And maybe here, the you can find here to nearby galaxy to like nearby star, the redshift becomes smaller. Okay, that is how we can use this graph to represent for redshift. Okay, and here we can find there's a Hubble law. Okay, the Hubble law just based on the knowledge we learned before. Like we knew that velocity, like we knew that the distance equals to velocity times time taken, right? Okay, so if we put velocity on the left equation, it becomes the distance over velocity equals to time taken, like this way. Okay, so distance over velocity equals to time taken, and we can say, oh, maybe right here, we can just make it reversed becomes velocity over distance equals to 1 over time taken again. So in the past lessons, we knew that velocity maybe means the velocity of the orbit or like orbital speed, right? But now velocity means the expanding speed. The distance means the star or like the distance between the star and the observer, okay? So here, 1 over time taken, we can just represent to another constant. It is Hubble's constant, is x0. Okay. So last lesson we have said like scientists has do many research that to find that the velocity is directly proportional to distance. Okay, so here f0 is the like the gradient right here. Okay, so we knew that f0 is a gradient, and here it's a constant value. Like here is 2.2 times 10 negative 18. So, okay, so you can find there is like a example. Here, maybe here we have a recessional velocity. Maybe here, if velocity equals to maybe 2 times 10 sevenths meter per second. Okay, so we can just put into the formula like here, 2 times 10 sevenths over the distance right here equals to 2.2 times 10 the negative 18th. Okay, so you can find the distance here. It is 2 times 10 sevenths or 2.2 times 10 negative 18. Okay, so if you knew two parameters, you can just refer another parameter. Okay, so this is Hubble's law or how Hubble's law tells them. Okay. And maybe you have a question. So you will ask me, teacher Mai Lin, you're gonna find that the Hubble story there's a H0 is a constant number and equals to 1 over time taken, right? So if we knew that 1 over time taken equals to H0, what about time taken equals to 1 over H0, right? So what is 1 over H0 means right here? Okay, so maybe you have this question, okay? So I guess you have the answer in your mind, right? 1 over H0 means a time about universe. So it means from the universe to explosion, it has a big bang until now, the time taken. Okay. So it is time taken for a big bang, or you can also say the time taken for the universe age. Okay. So here is about Hubble. So you can find there three like parameters they combine together. Okay. So here you can find that giant explosion and around 14 billion years ago. So 1 over zero means just 14 billion years. Okay. So this is why universe expand and how we are using formula to make a prediction about how to expand and like maybe next time. Okay. So here's the exercise. So try to solve the exercise, please. Okay. Okay, so I guess you have just looked through all the questions. So here, you want to find whether this distance is bigger or smaller. Okay, so how to determine the distance, like magnitude? We can set here from brightness of a galaxy, brightness of a supernova in the galaxy, right? So we can find that we want to find the speed of the recession of the galaxy, right? So we can say if we are just observing the brightness of galaxy, we can just find the distance, right? It's like a ball. If you're just moving away your body from the bulb, you'll find the bulb is releasing a lot of light, right? Releasing less light, right? Or you're very hard to observe it, right? So here we can say that if we're just determine the distance of the brightness of the galaxy, we can just determine whether the distance is bigger or smaller, right? So here we're choosing C or D. And the speed of recession, we can say, oh, if we just like change the wavelength of the starlight from the galaxy, we can just find the frequency change. Or just we can set here we have the redshift and the mean speed, right? So finally, we're choosing C as our final answer, okay? So distance, just using brightness to determine it, and the speed of recession, you can use the changing wavelengths, okay? Okay, another exercise right here, okay? Okay, so in this problem is that a distant galaxy is 20 light years from the Earth, right? So here we can say 20 light years, that means the distance here equals to the light passes through 20 years, right? So in each year we have 365 days, and each days we have 24 hours, and each hour we have 60 minutes, and each minute we have 60 seconds, right? This means the total time taken in a light year, and we have to time the speed of the light, right? 3 times 10^8 meter per second. Okay, that is velocity. So here's the distance. And if you want to calculate here, you can find the Hubble's constant is 2.2 times 10, 18, negative 18 second, negative 1, right? Okay. So here you can say, oh, maybe right here, the like Hubble constant is h like 2.2 times 10, 18 meters, sorry, second, negative 1. That means the Hubble constant h0 right here is 2.2 times 10 negative 18, right? So we all knew that velocity over distance equals to Hubble's constant. So here we can find the velocity right here is h0 times d. Okay, so you have to use a calculator to calculate here d times h0 and find the value. Okay, so this is today's lesson of this like Hubble theory and how to calculate the age of the universe. I guess you have learned something about this. Okay, and I hope you can do some exercise after the class and trying to really understand about Hubble theory. Okay. So maybe see you next time. Bye.